Hi again, my dear friends, and welcome back. Let's start lessons number 17, and we're going to continue on the linked lists. We introduced last time the concept of linked lists, and we reached a point where we created a node. We're going to continue on more operations on the list, as a matter of fact, and we're going to, as we move on, introduce some new functions and some new operations. Okay, basically the operations which we talked about last time were like this: create a new list node, and we already did that last time. And then what if we want to point to a particular node in the list? We're going to see how to do that this time. How to insert a new list on an existing, a new node, on an existing list. And then what if I want to delete a node from a list? And what if I want to traverse the list throughout and do some kind of operations on the nodes as we move on the list? I could do something like find a list size, the size of the list, number of nodes in there, or I could do something like find a target node, search for a particular target in the list, and maybe any kind of other operation on the nodes in the list, basically. It sounds very simple and very trivial. However, it's very important actually to remember that the list we're having now is actually no more contiguous like it was in the array, but rather they are linked together during these set of pointers that I have from one to another till I reach the end of the list like that. And the only information I have about this whole list is just the pointer in here, which we called head. So there's no way for me to know where this block or where this node is actually physically located in the memory, or where that is. This could comes after this one physically in the memory. I don't know. It depends upon the operating system when it was doing actually this allocation for this node or for that node. So I can never tell where it's exactly each one of these nodes is located. The only way to know that is to start from the very beginning, traverse through all the nodes till I get to the particular node that I want to process. And that's why linked lists are always actually accessed sequentially. So always remember this: sequential. And it's never random. Never random like it was in the case of arrays. Remember that. The only way I can actually access any of these lists, any of these nodes in these lists, is to go from the very beginning, one after the other, till I get to the node I want to access or I want to process. Okay, let's talk about the first function then. And this function is how to set the position of a certain particular node in the list. Basically, I would like to point to that node in the list, something like this. Here's my list, something like this. And here's head that points to the beginning of this list. And I would like, for whatever reason, to go to the position forward, like B positions, and access the node in here. To be able to get to this, actually I have to go through all of these nodes before that till I get to this point. Okay? And there is no way I can get to this position right away. Okay? So that's basically the goal of this function called set position. Basically, I have head here pointing to this long list down here, and I would like to return a pointer which points to the node that comes P positions from head. Okay? So basically, what I would like to get after this function is something like this: a pointer called current that points to this node that's P position after the head, the beginning of the list. The Pth, if you like, node in the list. Well, the only way to do that is basically, let's go here. Here's the list. Okay, here's my head. Of course, these are connected together. Okay, and let's say I would like to return a pointer to this one. Okay, the simple way to do this is basically to start from here. So I'm gonna put current at the beginning pointing to the first node. Okay, and then move forward each time till I get to here. Move forward P positions. How do I move forward from here to here? Well, simply make current, instead of pointing to head at the very beginning, make it point to current arrow next. That's what's current arrow next, this pointer in here. So instead of current pointing here, make it point to where this node actually points to. So make it point here. So that's like moving forward one step. Repeat this till you go B positions forward and then return. So that's basically what we're doing in this example. So the function set position, set the current, which is the name of the variable we're using, to point to a node at position P. The precondition for this is only that P is a valid position. What's a non-valid position? Well, a non-valid position if the value of P is negative, because I don't have any meaning for a negative position. I start always at node number 0, and then node 1, 2, 3, and so forth. So any negative number for P is not valid. Well, again, a non-valid value could be if P is actually larger than the actual number of nodes I have in the list. So let's say I have like 100 nodes in my list, and somebody asked me to go to position 110. Well, that's not an actual position. I don't have any nodes in there. So first of all, I need to check before I can go anywhere, is that P is a valid position. And then after that, I will start from the very beginning, move forward, doing basically this major step, till I get to the Pth position. So this is the precondition then. P has to be valid, greater than 0, and less than the list count, which always contains, as we said, the number of nodes in the list. The post condition for this, the list pointer, which is called current, points to the list node at position B. All right, it's not going to return a value by itself, but rather it's going to return a pointer called current to the node. So that's why it's going to take the position as an integer, go to the 10th node in the list, of course the list itself, and a pointer to a pointer of type list node called current. Why a pointer to a pointer? Well, because I'm going to change the value of the pointer. See what I mean? So, and that's why I need to pass a pointer to that value to be able to change it, because we always able to change pointers and not actual values. So if I want to change the value of the pointer, then I have to pass a pointer to that pointer. And that's why we're having double asterisk in here. Okay? Okay, what do I do then? Well, I'm going to start from the very beginning. So I'm defining integer counter, which is going to go from 0 to P, basically, to the Pth position. And then after that, I'm going to initialize some pointer of the same type, list Q, to point to head, to list, basically. And list here basically resembles the pointer to the beginning of the list. Okay, so that's the initialization step. What do I do after that? Well, I'm checking on the validity of P. Is it less than 0 or greater than the number of actual nodes I have? If that is the case, I'm sorry, I cannot do it. Error. Otherwise, yes, it's a valid position. Make Q, this pointer which we just initialized, to point to list arrowhead. So it points to the beginning of the list right here. Okay? So that's where I put Q. And then I'm going to start moving forward P positions. And for that, I need this for loop, which is gonna start from 1, the next one now. I'm already sitting at 0. Till I get to P positions forward. And each time I'm gonna increment my counter. Well, at each step of this loop, at each iteration of this loop, all I'm gonna do is this major step. Make Q point to Q arrow next, so that it goes and points to the next node in the list. And that's it. Keep going forward B times. And then definitely, after I exit this loop, I'm gonna have this pointer Q pointing to the Pth node in the list. Just return a pointer to that. So basically assign this pointer in the location pointed by current. So that's my return value. It goes here. Okay? And that's basically it. And then you're done with the else clause, and then you're done with your function set position. Very simple and straightforward. The second function we want to talk about, and it's a very important function actually, it's called insert. And that's when I want to insert a new node to an existing list. Well, where do we insert the list, this new node in the list? Well, several different scenarios. I could insert it at the beginning of the list. Here's an existing list. All right. Pointed by head. Okay. And here's the new node that I would like to add. Possibilities. I could want to insert it here at the very beginning and make it look like the first node in the list. So I want head to point here and this to have to continue with the rest of the nodes. Or I could insert it somewhere in the middle of the list, somewhere here. Okay, then I need to know which node comes after it and which node comes before it. And then I will send it and link it with the rest of the link right there. Or I could insert it to be the very last node in the list. And then instead of this pointing to null, it's going to point to this new node, and then the new node is of course is pointing to null, and that way I have a contiguous list after that. Well, why we're distinguishing between these? Because actually the way we're going to connect this new node in the list without losing any of the nodes already in the list is actually differs from one situation to the other in these different scenarios. Question is now how to insert the node to the list, whether at the beginning, middle, or to the end. And this is going to be what we're going to talk about in the coming few minutes. We're going to illustrate these scenarios graphically first, and then we're going to develop the program after that. Here's the list that I have at the beginning. Has certain number of nodes, I don't know. What matters to me is that there is head pointing to the beginning of the list. Okay, what's the first step? I need to create the node. Create a node means allocate memory for it, make a pointer point to it. In this case, we're calling it new node, this pointer, and make it point to null. Okay, where am I going to add it? Well, in this first scenario, I'm going to add it as the first node in the list at head, to be pointed by head. Well, if I make head point to it, then I'm afraid the rest of these nodes are going to be lost, because there's no other means that I can get to these nodes after I'm done with this move. So we have to be very careful. Remember, it's like a piece of rope. Okay, you're holding only the first one. Well, if you untie it and move it somewhere else, this whole thing flies in the air and I can never go back to it. So we have to be very careful in moving our pointers here. And that's the whole trick behind all of these functions. So first step, create the node. All right? After that, what do I do? Step number one, well, I have to tie the new node to the existing list first. So instead of making it pointing to null, I want it to point to the node which head is actually pointing to. So I go in the reverse order. I go to this pointer and tie it here. Fine, the one node could have two pointers pointing to it. There's no big deal with that. And this is legitimate in C. Okay? So first, tie the node with the first node, originally the first node in the list. So that's step number one. So this new node no more points to null, but rather it's pointing to the whatever head is pointing to. Okay? Now, it's safe after this to take this head and make it point here, because I'm having a full link, a complete link here for the rest of the nodes. So the step number two is to take head and make it point to here. Okay? So 3 steps. Create the node, that's number one, and then make it point to the first node in the list. After that, you can move head to point to the new list. And here it is. Here's the new node now. Head is pointing to it, and it has already been pointing to this node, which was the first node in the list. Very simple and straightforward. What if I want to add or insert a node in the middle of the list? What do? Well, here's the original list again. Step number one, create the node. Again, creating a node means allocate space, fill it with data, and make it point to null. Very simple, straightforward. And we have talked about this last time we met. Okay, next, I need to find where do you want me to insert the node. Well, what's important actually is to know the node which comes before it, not the one after it. Why? Because I want the one before it to point to it so that it points to the next and so forth. Okay? So it's important if you decide to insert the node. Let's say I have a bunch of nodes and here, last node. Here's head, pointers. Okay? And here's the new node I already created in what we call step number 0 there. All right? And now, the easier for me is to say something like insert the node right after this. Insert it here. Okay? In that case, well, simply, I can make this point to whatever this one is pointing to, and then I can move this one to go here safely. All right? However, if you ask me to add it before this, okay, I don't know what node pointing to this one. I don't know what's this pointer, because this is not part of this node, but rather it's part of some other node which I don't know. Like always, this node knows about this, but this doesn't know about this. I mean by that, it doesn't know where it's located physically in the memory. So I know about the one which comes after me, but not the one that's before me. Okay? And that's why if I would like to insert a node, I would like to know the node which comes before the position that you would like to insert the new node in. And this is very important, and you have to be very careful about it. Again, we're dealing with a chain, a linked list, okay? Pieces that are tied with ropes, pieces of ropes. And I always have to keep an eye on the rest of the nodes, because if I lose this tie, if I lose this piece of rope, then the list of the rest is gonna disappear and I can never access it again. Okay? So based on this, after I create the list, then what I'm gonna do, I will go to the position that is just before the position where I need to insert the new node. So I need to set position, and this is the function which we just developed actually in the previous example. So current here is gonna be set to point to the node previous to where the new node should be inserted. It should point to this node, okay, which is going to be just before this new node in the new list. All right? So that's step number 2. Step number 1, or which we call 0 according to the convention in here, is to create the node. Step number 1, set position. After I set the position at the proper place, I can now move forward with the scenario. Well, again, to avoid losing the rest of this list, I'm going to make the new node pointing to this node, which is actually comes after the node pointed by current. Okay? So this way, this whole list is now recognized through this new node pointer, so I'm not going to lose it. Okay? So instead of this pointing to null, I'm going to make it point to the next node. And then after that, since this whole thing now is in hand, I have it, I can now migrate this pointer to point to new node. So that's going to be step number 3. Break this sequence and take this pointer, make it point to new node. Of course, this is actually going to make a continuous list like that. Okay, and I'm not losing any data that way. We have to be very careful in the sequence of operations we perform here. It's very important. Okay, after this step, here's the new node which has been inserted. Current was pointing here, and I added this new node right after the node pointed by current. Okay, and the rest of the sequence, the rest of nodes are there. Okay, the third scenario is when I want to add the new or insert the new node at the end of the list. This is perhaps the easiest, simply because there is nothing after the last node, so I don't have to worry much about keeping information about other nodes. There are no other nodes actually in the list. So basically, what you need to do in here is again, create the node, and that's step number 0, like usual. And then, after that, well, the easiest thing, this is pointing to null. Well, I don't want it to point to null anymore. Okay? Can I move it right away? Yes, there's no problem because I don't have anything after that to worry about. Okay, then simply just take this pointer, make it point here, and we're done. Okay, this one is pointing to null, and it's going to be the last node in the list. So basically, just do this after you create the new node. All right? And we're done. Simply. And the new node is now inserted as the last node in the list. All right? So these are the 3 possible scenarios, 3 possible ways of inserting a node into a list. Okay, let's now develop the function which performs the insertion operation. Here's the prototype for the function. It's called insert list, which inserts a node to a list, inserts a new node to a list. That's what it says. The prototype for the function, it's going to return a value of type void, nothing to return basically. All I care about is just create a new node and insert it to the list at the specified location. So basically it takes 3 parameters. The first parameter is an integer p, and this integer p tells me the position of where you want to insert the new node. Okay, let's say 5. That means make the new node the 5th node in the list. Well, then I have to point to the node at position 4 so that I can make this one at position 5. You know, you remember we said I have to know the node or the address of the node before the position I want to insert. All right? And then the data itself that I need to fill in the new node, because step number 0 is always to create the node, initialize it. So I'm going to initialize it with this information, x. And this is of type list entry. It depends upon whatever kind of data we have in the nodes, as a matter of fact. And then a pointer to the list itself. Okay, the precondition for this is that this list already exists, it has been created, all right? and that this data in here is actually some valid data. And that's a legitimate assumption, of course. And that the position P where you want to insert the new node into is actually a valid position. And again, we talked about valid positions. No negative positions, all right, and no positions beyond the maximum size of the list that we have at that moment. All right. The post condition. Post condition, basically, a new node has been created. The data X has been inserted. And this new created node has been inserted at the specified position P in the list. Okay? The entry formerly in position P, this one, oops, dot, 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 null down here, okay? And let's say this is node number P in the list, and of course this is number P plus 1. Well, I have a new node now, and I want this node to be at position P, so I want it to go here instead. All right? Well, as we said, we're going to make this point to this one and make this point to this one, all right, with the rest of the operations we already talked about. What's important, if this is going to be number P, now this is going to be P number 1, P plus 1, and the one after that P plus 2, and so forth. Okay, and the total number of nodes in the list is now one extra than the previous case. Okay, so the whatever node I had previously at position B is going to be at position P plus 1, and so forth for the rest of the nodes in this part of the list. Usage. Basically, I'm talking about what other functions I'm going to be using in the middle of this function. I'm going to use the error function to display some messages to the user in case of errors. I'm going to use the function create node, which we developed earlier, to create the new node. And I'm going to use the set position function to go to this position before I can insert the new node. All right, let's see. The code itself. Insert node. Integer P, entry, X, and a pointer to the list. Okay, I'm going to define some local variables which I'm going to use along the road. And a pointer of type node or list node called the new node, which is going to point to the new node to be created, because I'm going to create a new node. And this new node is going to be inserted in the existing list. And I need another pointer which points to nodes as well, called current. And this current is going to start from here, and it's going to go along the way to point to this one just before where node has to go, where new node has to go. Okay, so these are both pointers that point to nodes, all right, and I'm just going to use them locally within this function. And then after that, I'm going to start with this basic check to see if actually this position is a valid position or not. So what I'm saying in here is something like is P less than 0? If that is the case, then no, you're out of the range of the list. Or is P larger than the count? Again, if that is the case, then you're outside the scope of the list. So in either this case or that case, call this function which is called error and display a message to the user basically which says, no, you're out of the scope of the list. Sorry, I can't add any nodes in there. Otherwise, if yes, it is a legitimate valid position, then what do I need to do? Remember, step number 0, always in all scenarios, whether at the beginning, middle, end, is to create a node. So basically, I'm going to call this function create node, which takes only the data to it. And this create node, if you all remember, returns to me a pointer that points to an already created node. That what it's going to do basically, allocate in the memory, somewhere in the memory, wherever available, space for a node. Take the data x, place it inside that one. Okay, make it point to null after that, and return a pointer which points to it. And this pointer is our local variable new node. Okay? What do I do after that? Well, now I'm going to distinguish between the three scenarios we talked about, either at the beginning, in the middle, or at the end. If position equals 0, that means we are attempting, this is position 0, right? I want the new node to be at position 0. That means I want head to point to that. It's the first node in the list. All right, so if that is the case, then let's do the two major steps we talked about when we inserted to the top. Here's the list of nodes, and new node, which I just created and filled with data, is going to go here. Head is pointing here. Here's my list. Okay, so what I'm going to do, step number 1, is to make new node arrow next point here, so that I tie it with the rest of the nodes. All right, so I won't lose any of the nodes in the list. And then I can safely, so this is step number 1. And step number 2 is this. Is to now make head pointing here. All right? Let's see these two steps. So in this case, if P equals 0, then new node arrow next, this pointer goes to wherever head is pointing. So it equals to list arrowhead. So this means make new node pointing to this. So at this moment, this node in here actually has two pointers pointing to it, head and this new node arrow next. All right? And that's legitimate, no big deal. I can have like 10, 100 pointers pointing to the same location. What's wrong with that? All right? I just want to double check to make sure that I don't lose my data. That's what's important. All right? So that's step number 1. And the sequence here is very important. It's very crucial. So this is the first step then. Make new node arrow next point to wherever head is pointing. And now you can safely move head. So you say something like list arrowhead equals to new node. So make head now pointing to wherever this new node pointer is pointing. So basically point to this node. And we're done. So this is step number 1, the first line, and that's step number 2 in the second line. Okay? That's the case of P equals to 0, inserting at the beginning. Else means if I want to add it anywhere else along the list. Insert in the middle or at the end, it doesn't matter, because we're going to do the same steps. The only difference between adding in the middle and in the list is that in the middle, here's the new node, okay? I'm going to make it always this point to wherever this node is pointing to, and then I'm going to take this pointer and move it here. So this is step number 1, and this is step number 2. All right? Well, in this, when I add at the very end, actually, we said I'm going to make this point to wherever this is pointing. Actually, this is pointing to null, right? So no big deal. I can do it. It's pointing to null again. So even if I say that again, it's not going to hurt at all. Okay? And then I'm going to make this point here. And that's step number 2. So instead of looking at two different scenarios, else, if, and so forth, we're simply going to do the same thing in here. And in here, we're making a redundant assignment, but that's okay. So in this case, what I'm going to do, first, I need to go to the position just before the position I want to insert the new node into. I want to insert this new node at position P. Then I need to go to position P minus 1. And that's why the first step I'm going to do is to call this function setPosition at P minus 1 in this list, okay? And I'm passing to this the address of current. Remember, I had asterisk current in there. So I have to pass the address of the pointer which points to the node. A pointer to a pointer, okay? So as a result of this, when it comes back, I will have a pointer called current actually pointing to this. All right? The node just before the position I want to insert the new node into. What do I do after that? I'm at this position. Well, okay, step number 1, in here or in here. That's step number 1. Is to make new node arrow next point to whatever comes after this one. So whatever this pointing to, and that says new node arrow next equals to current arrow next. So please make the new node arrow next, this pointer, pointing to whatever this node is pointing to, as a matter of fact. Okay? And that's basically what we do in here. So this is step number 2 in the process. This is step number 1, step number 2. And now I can safely, once I have this tied here, that means the rest of the nodes are in a safe place now. I have access to them through this new node pointer. I can now break this sequence and move it to point to new node. So the next thing I'm going to say, current arrow next point to new node. So current arrow next equals to new node. Again, it's very important. The sequence here between these two is crucial. If I perform this before I do this, then the rest of the list is gone. And this is very important. I would like you to exercise on these things actually on paper, graphically, before you can go and write this on the computer as a program. Okay, so I inserted the new node, whether in the middle or at the end, it's the same thing. That's the second step. What do I do after that? Well, just remember that you have a new entry that has been added in the list. So all you have to do is go to your list and to this member, which is called count, which always gives the number of entries in there, and just increment it and return. Okay, so that's basically what I need to do. Very simple, very straightforward. It is just we have to be very careful in doing this. Very, very careful. Please try this graphically, several scenarios, the different positions, and then go to your computer, implement this function, and see how it works. Okay, I encourage you highly to implement every function we write in here on your computer. It's good to get a grasp of the C programming using linked lists and building functions like these. It's very important. Okay, that's all I want to talk about in today. Next time we meet, we're going to continue on the other operations that we're going to perform on linked lists. And definitely to go back to this class, to this lesson material, you can go to the internet, UNINETTUNO website, click on the MidNetU project, and you're going to see lots of interesting stuff. Thank you very much for watching, and I will see you next time. Bye-bye.